Hello students, welcome back to the fifth video of this playlist. So in this video we will be solving question number 5 from June 2024 Statistics 2 paper. So let's see what's the question number 5 from this paper is about. Okay, so basically question number 5 it's a combination of different topics from your statistics 2 syllabus. If I give a short review on question number 5, it would be like the concepts behind this question number 5. It's from binomial distribution at first, and then you need to consider Poisson distribution, and then you need to consider continuous random variable. Like this is basically a combination of 3 types of distributions in the same question. And at last, the part D, it is basically combining independent variables. So in order to be able to solve question number 5, definitely you should have finished chapter number 1, that is binomial distribution, chapter number 2, that is Poisson distribution, and then chapter number 5, that is continuous uniform distributions. So you should have definitely finished these 3 chapters in order to be able to solve this question. And also besides these these 3 chapters, you should have also knowledge about chapter number 4, that is continuous random variable. Okay, so let's get started with question number 5. So a receptionist receives incoming telephone calls and should connect them to the appropriate department. Okay, fine. A receptionist, she is receiving calls, and she has to connect the calls to the right department. Okay, so the probability of them being connected to the wrong department, the probability of connecting to the wrong department on the first attempt is 0.05. So like when you will be reading the question, not the question, basically in statistics there are always very long passages, isn't it? So when you will be reading the passages, try to figure out like what are the details given, and from the details you should figure out what type of distribution does this event follows. Okay, so in that case, look, there you see the probability is given. So let's figure out what's the parameter, like which distribution has a parameter with probability p. Here p is 0.5 given, right? P is what? 0.5 given. Okay, since the parameter, that is probability p, it's given 0.5, so what we can understand, which distribution has parameter p? This is nothing but binomial. A binomial distribution has a parameter p. Like a binomial distribution is always distributed with n number of trials is fixed, and probability p, the probability of the wanted outcome, it's p. So p is here 0.5. okay, so when you read the passage, you should figure out like what would be the distribution of the given event. Okay, so at first in part A they are asking what? Okay, they took before part A, a random sample of 8 calls is taken. Okay, they have taken 8 calls. The number of trials is basically n is here 8. Fine. Okay, so the first question, part A, find the probability. We need to find out the probability that at least 2 of these calls are connected to the wrong department. Okay, at least 2 of these calls are connected to the wrong department. So at first consider the distribution, part A. For part A, what we can consider, x is distributed binomially with number of trials is 8, and probability is 0.05, right? So what we can say here, x is what's x there? X is basically what? The number of calls that is connected, the number of calls that are connected, okay, that are connected to the wrong department, right? To the wrong department. Okay, this is X. Fine. So we need to find out at least how many? At least 2. So at least means what? Probability of X at least means greater than or equal. Okay, greater than or equal to, right? So this is what? This is 1 minus probability of X less than or equal what? 1, right? So what would be that? So 1 minus, we need to find out the probability of X less than or equal 1. So let's see the distribution table. You will have these in the formula booklet that will be given in the exam. Okay, exam question. Like besides your exam question, it will be given a formula booklet. So on the statistics 2 part, S2 part, you can see like these tables. This is for binomial. So after going to binomial distribution table, this is showing the cumulative distribution. That means continuous, like the sum of the probabilities. So we got n equals to 8, and we need what? X less than or equal 1. But consider the probability is what? The probability has to be how much? Okay, the probability has to be 0.05, isn't it? The probability has to be 0.05. So let's see, where is 0.05? 0.05. Yeah, the first column, isn't it? It's 0.05. Okay, so here probability of X less than or equal 1. This is what? 0.9428. 0.9428. Okay, so we got 0.9428. Okay, 0.9428. So let's see, we got 0. What? Using highlighter. Okay, 0.9428. Okay, so the value that we got here, it's what? 0.9428. Okay, it was having problem. Okay, 9428. So 1 minus 0.9428 is what? 0.05 0.0572, isn't it? 72. Okay, so this is the answer for part A. That's it. Very straightforward. Next, part B. The receptionist receives 1000 calls each day. How many? 1000 calls. 1000 calls. Okay. Use a Poisson approximation. They have already mentioned you need to use what? Poisson approximation. Why we need to use Poisson approximation here? 1000 calls. If you check out the distribution, that cumulative distribution table that is given in the formula booklet, basically it is up to n equals to 50. Okay, so 1000 is a very large number, right? And for large numbers, we know that we have to do what? We have to do approximation, isn't it? Okay, so yeah, that means in this question we also need some concept from approximations, chapter number 3 of statistics 2. So I didn't say that earlier. Okay, so we need to use approximation, Poisson approximation, to find the probability that exactly 45 callers, exactly 45, okay, are connected to the wrong department on the first attempt in a day. Okay, so that's a new distribution now, right? A Poisson distribution. So let's consider a new variable for that. Let's consider this as what? Y. Okay, for part B we can consider y. It's distributed. Y is distributed how? At first it's binomially distributed with 1000 calls. Okay, it's definitely it is binomially distributed, right? We know that already, and its probability is 0.05, and so it can be approximated. This sign represent equivalent to what? Z distributed Poisson with what? Okay, now there's a concept from approximations. We can use Poisson approximation to a binomial distribution. Okay, we can use a Poisson distribution to approximate a binomial distribution if n is large and p is closer to 0. Why? Because when p is closer to 0 and n is large, then np is what? The mean of a binomial distribution. The mean and the variance np times 1 minus p would be equal, and that's the concept of Poisson distribution, that in Poisson distribution the mean and the variance would be what? Closer, right? So let's see, 1000 times 0.05, you will get what? 50. So the value for the value for what? The lambda here for Poisson distribution, it is the mean. So this is what? 50. Okay, so this is what? 50. Okay, so what is y? Y is basically the number of calls, what? Calls connected to what? To the wrong department in a day, right? It's in a day. Okay, department okay in a day. Okay, so what we can say here, the variable y, it is the number of calls that is connected to the wrong department in a day. This is the variable y. So it has been approximated using a Poisson distribution with mean what? 50. Now the question asked for how many? Like the question asked for exactly how many? 45. Okay, exactly 45 callers has been connected to the wrong department. Okay, so we need to find out probability of y being equal to what? Probability of y equals to how much? 45, isn't it? 45 callers being connected to the wrong. It can be approximated what? Probability of z equals to what? 45, right? Okay, now the question is, do we need continuity correction here? Like sometimes we need to write 45.5, 40, or like when you are converting, when you are doing the approximation, sometimes you need to do continuity correction. So do we need continuity correction here? That's a good question. We won't need any continuity correction here because we are approximating a discrete random variable using a discrete variable. Okay, not variable, this is basically distribution. We are approximating a discrete distribution using another discrete distribution, because binomial distribution is also a discrete distribution, and Poisson distribution, this is also a discrete random distribution. Okay, so in that case, since both are discrete, so we don't need to do any what? Continuity correction here. Okay, so probability of z equals to 45, it's what? The formula for what? Poisson distribution, E inverse lambda is what? 50 times what? Lambda to the power x. X is how much? 45 over x factorial, right? So 45 factorial. So what would be the value here? 50 to the power 45 times E inverse 50 over 45 factorial, right? 45 factorial. Okay, so what would be the value? Okay, the value I got, that is 0.0458. 0.0458 8. This is the answer for part what? B. Fine. So for part B we got the answer 0.0458 up to 3 significant figures. So this is the probability that exactly 45 callers are connected to the wrong department. That's it. Next, part C. The total time t seconds taken for a call to be answered by a department after the call has been connected, like when the receptionist is trying to connect the call, it takes t seconds, okay, to connect the call to a department. So it is distributed what? With continuous uniform distribution over the interval 10 to 50. Continuous uniform distribution. This is a concept from chapter number 5, right? So we need to find out the probability of t greater than what? 16. Probability of t greater than 16. So how can we do that? Look, let's have a look. For part C, we need probability of t greater than what? 16. So probability of t greater than 16 would be what? T is distributed what? Between 10 to 50, right? T is distributed between 10 to 50. Since t is distributed from 10 to 50, we know that the probability to, like, how can you find out the probability in uniform distribution, like continuous uniform distribution? This is what? The upper limit minus the value, that is 16. Since t greater than 16, so we need above 16. So 50 minus 16 over what? The interval, the range 50 minus 10. Okay, so the value would be what? 50 minus 16 is what? 34. So 34 over, it would be 34 over 40, right? So 34 over what? 40. So 34 over 40, it's what? If you can simplify it, it would be 17 over 20. This is the answer. Fine. Next, what's next? Part D, the last part of this question. The number of calls the receptionist receives in a minute, okay, in a minute interval, is modeled by a Poisson distribution with mean 6. It is distributed using Poisson distribution with mean 6. The lambda here, it's what? 6. So try to figure out, like, what are the details given. Like, part D is basically a bit tricky question, because it is what? It is a combination of independent events. It is a combination of independent variables, okay? So they said the number of calls the receptionist receives in a minute. Now this is a different what? Different interval, 1 minute interval. Previously it was for a day, now it is what? One for a minute. So in 1 minute, the number of calls that is received by the receptionist, it is what? Distributed with Poisson distribution with mean lambda 6. The receptionist receives a call from Jia and tries to connect it to the right department. Okay, so the receptionist receives a call from a person called Jia, and he is, like, the receptionist is trying to connect it to the right department. Okay, fine. So part D, very important. Find the probability that in the next 40 seconds, in the next what? 40 seconds, Jia's call is answered by the right department on the first attempt. By the right department on the first attempt. And look, there are 3 combinations. Look, the call has to come in the next 40 seconds. Sorry, the call has to be accepted, right? Has to be answered by the department in the next 40 seconds. This is one condition, one event. This is one event, one independent event. Then it has to be what? Accepted, answered by the right department. Okay, this is the second independent event. So we got how many? 2 independent events. And at last, and the receptionist has received no other calls. How many? 3 independent events together in a single question. when you will be reading the question, definitely you should be able to figure out the events. If you can't figure out the events clearly, like independently, then you would not be able to answer this question. Okay, so the first option is that the first focus has to be to find out the events. Okay, the independent events. So like I marked out the events here. Next 40 seconds, the call has to be answered within next 40 seconds, and then it has to be answered by the right department on the first attempt, and at last it has received no other calls within that time. Fine. Okay, now let's consider the three events. We need the three probabilities of the three what events. Okay, so at first, the probability that the Jia's call has to be answered within the next 40 seconds. Now, in the before this question, they have given like in 1 minute interval how many calls are getting received by the receptionist. Okay, this is distributed Poisson with Poisson distribution. It isn't the distribution for the time taken to answer a call, right? The time required to answer a call, it is given in part C, right? For a call to be answered, right? To be answered by a department, it is what distributed with continuous uniform distribution within the interval 10 to 50. Okay, so we will use this distribution to find out the probability that in next 40 seconds the call will be answered. Fine, so let's find out that. I think you got the hold of the question because I have described already the three events. First, what we will be finding out? We will be finding probability of t less than 40. That means the time required to answer the call by the receptionist is what? Less than 40. That is what? Less than 40. So 40 minus the lower interval is 10 over 40 minus 10 over what? 50 minus what? 40, the range. 50 minus 10, the range. Okay, so we'll get what? 30 over 40, that is basically 3 over 4. Fine, that is 3 over 4. Next, this is what? The first independent event. Next, let's see what's the second event there. The second event says the call has to be answered by the right department. So what's the probability of answering the call by the right department? This is nothing but 0.95, right? Probability of answering the call, probability of connecting the call to the wrong department, this is 0.05. It's 0.05, not 0.5. 0.05. Okay, so okay, did I use in part A, did I use 0.05? Yeah, it's fine. Just I wrote 0.5 here. It should be 0.05. Okay, so the probability of answering the call by the wrong department, it is 0.05. So answering by the right department, this would be 0.95. Okay, so we got the value for P. That is what? Probability of right department. Okay, right department, this is how much? 0.95. So done. We got the two independent events, the probabilities for the two independent events. The last one is what? The last one is no other calls has been received in the next 40 seconds. Okay, so we know that in 1 minute interval the number of calls received is what? It's 6, right? So consider k. K is basically the number of calls. Let me write k. K is basically what? The number of calls received in 40 seconds. Okay, in 40 seconds, number of calls received in what? 40 seconds. So this is what? K is distributed how many? In 1 minute there is 60 seconds, this is what? 6. So in 40 seconds this is 4. Fine. K is distributed, right? It should be Poisson distribution, right? K is distributed Poisson distribution with mean lambda 4. So there should be no calls being answered, like not answered. There's no calls being received in the next what 40 seconds. So k equals to what 0. So this is what E inverse lambda. E inverse lambda is what 4. E inverse lambda times lambda to the power x. Lambda is 4. 4 to the power x is 4 to the power 0. This is 1. So E inverse 4 times 1. This is basically E inverse 4. So then we got the 3 probabilities of the 3 independent events. Now then last answer is what? We need the probability. So the probability you will get here. I'm just writing it. P equals to what? What would be the probability? The 3 events are totally independent. So for the 3 independent events to occur at the same time, we know that the probabilities has to be multiplied, right? For independent events, the probabilities has to be what? Multiplied. So let's multiply the 3 probabilities. What you will get? 0.95 times 3 over 4. Okay, let's maintain the sequence. 3 over 4 comes at first. Then 3 over 4, what was that probability? The probability of what? Answering the call by the receptionist within 40 seconds, right? Then what? Then it is 0.95, like connected to the right department, times what? E inverse 4. E inverse 4 is what? No calls has been received by the receptionist in the next 40 seconds. So what would be that value? 0.75 times 0.95 times E inverse 4. This is, what's the value? 0.0130. 0.0130. Okay, so this is the value for the required probability, for the asked probability. Okay, so now how many decimal places you can consider? Okay, at least how many significant figures they considered? They considered at least 2 significant figures, right? Like 0.95 or 3 decimal place is fine. You can consider 0.0, so it can be considered to 3 decimal places. The final answer, give the final answer to 3 decimal place. 0, 1, 3. Okay, it is up to what? 3 decimal places. That's enough. Understand? So this is all about what? Question number 5 from Statistics 2 June 2024 paper. Okay.